Hello everyone, welcome to the lesson on mixtures. Now, what is a mixture? Well, it's literally where you take two different things and you add them together and you mix it all up and you produce another solution. So for example, you might have this mixture over here, okay? Now, this isn't relating to this question. This is just a quick little introduction. Maybe you have a solution here which is 30% orange juice, or let's say orange, and then the 70% would be water. Okay, but we usually won't mention that part, so we'll just say 30% orange juice, and then you're going to add that to a maybe it's a bit of a smaller one. So maybe this one here is 2 gallons, for example. This one is 2 gallons, and then this one is 1 gallon, and it is a 10% orange. 10% orange. Now you're going to take those two solutions and you're going to mix them together and you're going to produce this 3-gallon container, because it's 1 gallon plus 2 gallons, so that makes 3 gallons, and it's going to have some orange juice. Okay, but now what we would want to do is to try maybe work out the percentage. You can't just say 30 plus 10 is 40. That's not the way it works. So we need to work out what the final orange percentage would be in that solution. Okay, so that's the general idea of a mixture. You take solution 1 plus solution 2, and you're going to produce solution number 3. Okay, so now there is a general way of doing these questions, and if we stick to this basic general way, you'll see that these questions are actually very, very easy. So let me show you what you do. Let's give it a fancy name. Let's call it the double bracket method, okay? So we'll go like this, this, plus this. Wait, let's get some more space quickly. So we're going to go... Okay, so there's the double brackets, okay? So... Okay, I've just made that solution a bit smaller. So what you would do is you would say percentage of solution 1, and then this would be the mass or the volume of solution 1, and then you would say percentage of solution 2, and then the mass or the volume or whatever of solution 2, and then this would be the percentage of the final mixture, which would be this one, and then this would be the mass of the final mixture. Something to keep in mind, however, is that the mass of this container over here is always going to be the mass of number 1 plus the mass of number 2. That should make perfect sense, right? So this mass over here, your final mass, is always going to be the mass of solution 1 plus the mass of solution 2. Okay, that should make sense. I mean, if you take 2 gallons and you add it to 1 gallon, you're definitely going to make 3 gallons. That's pretty straightforward. So I want you to remember this. This is the general thing that we are going to be using throughout all of these mixture questions. So write that down, and then if you stick to that, you will be okay. Okay, so let's see how it works. We're going to do quite a few examples in this lesson. So by the end of this lesson, you will understand what to do. Okay, so it's this solution, this formula that I want you to remember, and then I want you to also always remember that over there. And you're going to see that being used over and over and over and over again and again and again in this lesson. By the way, the SOL, sorry, that was solution. If you didn't catch that in the first part, I said solution, but I just wrote SOL for short. Okay, so let's start. A metal alloy weighing 1.4 pounds and contains 30% silver is melted and mixed with 2.1 pounds of a different alloy which contains 80% silver. What percent of the resulting alloy is silver? Okay, so this is very easy. We've got solution number 1, which has a mass of 1.4 pounds, and 30% silver. Great. Then we've got, we're going to mix that up with solution number 2, which is 2.1 pounds and is 80% silver. And that's going to be combined. Obviously, they're going to mix it all up, and that's going to form some type of solution over here, which we don't know what the percentage is, but we should know what the mass is. Guys, I mean, if you think about it, it's 1.5 pounds plus 2.1 pounds, so that would be 3.5 pounds. That's what we said here. Okay, so now what we can go do, that's just the little picture I wanted to show you. Now we can go make use of this little formula over here. So we can take the percentage of the first one, so 30%, multiplied by the mass of the first one, which is 1.4, plus the percentage of the second solution, multiplied by the mass of that second solution, gives us the percentage of the second solution, which we don't actually know. So we'll just say x, and then we will multiply that with its mass, which is 3.5. How easy was that? Now, on your calculator, if you type in 30%, that is actually 0.3. So let's rather say 0.3. And if you type in 80% on your calculator, that is 0.8. So now what we do is we just solve. So we multiply these two together, for example. And so that's 0.42 plus the second part. If you multiply that together, you get 1.68. And then that's just equal to 3.5x. Okay, then I'm just going to combine the left-hand side. So the left-hand side would be 0.42 plus 1.68, which is 2.1. And that's equal to 3.5x. Now we're trying to get x by itself, so we will divide this side by 3.5, and that means you also divide this side by 3.5. And so if you had to work out x, you get 0.6, but remember we want to convert that decimal back into a percentage, so we say x equals to 0.6 multiplied by 100, and so that would be 60, okay, that looks like I'm saying 66, it's 60% as our final answer. So what percent of the resulting alloy is silver? 60%. Okay, so you can try this one yourself, but what I'm going to quickly do is just write out our little formula. So it's always the percentage of solution. Let's write it out nicely. Solution 1. I decided to actually just go write out the formula for you guys. So this is something that you always want to keep in mind, okay? And then we've also got this little formula here, which is just to remind us that the mass of the first one plus the mass of the second one will be the mass of the final solution, because you're just adding them together. So here we have a metal alloy which weighs 6, and something I wanted to mention is that throughout this lesson that we're going to be doing now, I'm going to be asking the questions in different ways, okay? So don't think that it's just going to be the same type of way. I'm doing 2 of the one way. I'm using 2 of a different method and then 2 of a third method. So we'll be doing 6 questions in total. We've already done number 1. And I'm going to be showing you all the different ways of them asking it. Okay, so here we have a metal alloy which weighs 6.2 kilograms and contains 75% iron, is melted and mixed with 4.8 kilograms of a different alloy which contains 20% iron. What percent of the resulting alloy is iron? Okay, so I'm not going to go draw pictures and stuff now. I think you guys understand it, so we're going to put the brackets. Okay, so the first solution is 75% iron, so we can say 75%, and it has a mass of 6.2, and then so we've used that and we've used that, and then it's mixed with another alloy which is 20% iron, so 20%, which is 4.8 kilograms, and then the resulting solution is, oh, that's what we're trying to work out. Now, some students are like, okay, well, what do we put over here? But remember that the mass of solution 1 plus the mass of solution 2 is the mass of the final solution. So if this is 6.2 and this is 4.8, then you can just add them together. So you can say 6.2 plus 4.8. Easy as that. Hey, now the next step is just to get rid of the percentage. So let's rather say 0.75. You could just say that from the beginning, to be honest. And then just do that, and then 6.2 plus 4.8 is 11, so we can just say 11x. Now it's easy. You just add all of these together. So I'm just going to type all of that. So 0.75 times 6.2 plus 0.2 times 4.8, and that gives us 5.61 equals to 11x. And then you just get x by itself by dividing both sides by 11, and so x would be 0.51, but that's not the final answer. Remember, you want to turn it back into a percentage, so we can say therefore x is 0.51, multiply that by 100, and that'll give us 51% as the final answer. in this next question, they're going to ask it in a slightly different way. What I mean is that in the previous two examples, we kept having to calculate this part over here. Now they're going to ask it in a way where you might have to calculate this one, or you might have to calculate that one, or I don't know. Let's see how they do this one. So it says, how many pounds of a metal containing 40% platinum, okay, must be combined with 10 pounds of pure platinum? Ooh, that's a good one. Pure platinum. That's going to be interesting. You want to stick around to understand what that means, to form an alloy containing 80% platinum. Ah, okay. So this is a good one. So we've got a mixture plus another mixture, and that equals the final mixture. Okay, that's always how these questions are, so that doesn't change. So it says how many pounds of a 40%? Okay, so the first one is a 40%, so say 40%, but we don't know how many pounds. We don't know how many pounds, so that's our unknown. Then it says, now listen carefully, guys, must be combined with a 10-pound mixture of pure platinum. Oh, okay. Remember in the beginning of this video, I mentioned the orange juice, and I said that maybe you have like a, I don't know, like a 30% orange juice. What that meant was that the whole solution is 30% orange juice and 70% water. So it wasn't like only orange juice. Okay, it was a mixture of 30% orange juice and 70% water. This one over here is not pure either, because it's 40% platinum, and the other 60%, well, we don't know what it is, but it's other stuff, so it's not pure. But when they say that something is pure, then what do you think the percentage is? Well, excellent and well done to you if you said it's 100%. If something is pure, it means that it is the only thing in that solution. There is no other thing. That's what pure means. Okay, so that's important that you get that part. And then the rest is pretty easy. They want us to form an 80% final solution, so this one will be 80%. And what would its mass be? Well, that's interesting, because normally, if we use this formula, we would add these two values together, right? But that's okay, because what we can do is just say that this is X pounds. Then what would this be? Well, it would just be X plus 10. Because we're just adding this one and this one together. Because remember, to find, if you add these two together, that gives you the final solution. Now what we can do, let's just go use our good old trusty formula over here. And so we can just say 40%, or let's just say 0.4. And then the mass of solution 1 is X. We don't know what that is. And then the percentage of this one is 1. So you can say 100%, but if you type 100% on your calculator, 100% is just a 1, okay? So I hope you're used to that, or just get that in your head, or make sure you understand that. That's what I'm trying to say, like, that it's just going to be a 1, okay? And then the mass of that one is 10, and then the mass of this next one, the percentage first is 0.8, and then the mass is X plus 10. And there we go. I hope you understand that, guys. So let's go solve this now. So this will just be 0.4x plus 10 equals to, now this 0.8 is going to be distributed throughout, and so that's going to be 0.8x plus 8. Now you're just going to solve for x however you feel like doing that. I'm going to take the x's to the right hand side, and I'm going to take the numbers to the left hand side. And so what we're going to do is we're going to end up with 0.8x minus 0.4x, and then on the left you would end up with 10 minus 8. And so therefore we're going to end up with 2 on the left and 0.4x on the right, and so x would be 2 over 0.4, and so x would be 5. Now here we don't have to multiply by 100 because we're not looking for the percentage, but instead we're actually looking for the mass. So we could say that the final answer then is going to be 5 pounds. Oh, that looks like 51. Got to be careful here. Don't like the symbol pounds. So we can say 5 pounds like that. Here's our next one. So how many kilograms of copper, which costs $3 per, don't worry about this. Okay, so remember I kept using a percentage, but it doesn't always have to be a percentage. Sometimes this percentage will also be a cost per unit, or it will be a unit cost. Okay, it can also be a unit cost. A unit cost, what I mean is like dollars per pound. I mean dollars per kilogram, or dollars per pound, or something like that, okay? So it's always the price and then the mass. That is called a unit cost. So sometimes they'll use that instead of a percentage, okay? So it says how many kilograms of copper, which costs $3 per kilogram, must be added to 5 kilograms of tin, which costs $9, to make bronze, which costs $5 per kilogram. Okay, so once again, we're just going to go do the same technique. Okay, so it says how many kilograms of copper. So we don't know how many kilograms of copper, so we'll just say X. Oh, no, sorry, that's here. The mass, remember the mass is over there. And then the unit cost, or the percentage, these are together and these are together. So that would be 3. So you just put a 3 over there, okay? And then this one over here must be added to 5 kilograms, which costs $9 per kilogram. So the unit cost is 9 and the total mass is 5, okay? To make bronze, which costs $5 per kilogram. So that's 5 over there because that's the unit cost. Remember, this could also be unit cost. And then the total mass. Well, the total mass is normally this one and this one added together. So that we'll still do that, and we'll just say X plus 5. Okay, so I just want to remind you once again, they can use percentages or they can use unit costs. A unit cost is a per kilogram or something like that. It'll always have a little line like that, and then it'll say, or it'll just say, they'll say something like $3 per kg or something like that. Okay. And so now we can go and solve. So that would be 3x plus 45. Now we're just going to distribute this 5 in here. So that's 5x plus 25. And now it's just a matter of solving for x. So we can take the 3x over. So it becomes 5x minus 3x. And then on the left we can say 45 minus 25. And so that's going to be 2x is equal to 20. And then you can just get x alone as 10. But let's just make sure they've answered the question. How many kilograms of copper? Okay, so it's 10 kilograms. So I've just updated the formula. Okay, so sometimes it's a percentage solution or a unit cost. Okay, and we said that the unit cost is like dollars per kilogram or something like that. So here it says, to build the garden of your dreams, you need 15. I think this is going to be a different type of way that they ask the question. Remember, I said in the beginning of this video, we're going to look at the different ways. This is going to be another different way. So let's see. To build the garden of your dreams, you need 15 cubic meters. That's like a volume. Okay, so that's a volume. And this can be mass or volume. Okay, so this is mass or volume. I didn't update the notes on that part. Okay, there I've updated it now. So we've got mass, volume. Okay, so it says it's pretty, yeah. So to build the garden of your dreams, you need 15 cubic meters of soil containing 48% clay. Okay, so I think that's what we're trying to get to. So that's this part. Okay, that's what makes this one interesting. They're going to tell us the final thing, but they're not going to really tell us much about the starting materials, which is these ones over here. It says that you have 2 types of soil you can combine. You can use a soil with a 55% clay and soil with 40% clay. How much of each one should you use? Oh, okay. So this is quite good. So what we have here is, if we use our double bracket method, right, so, okay, so the percentage of the first solution, let's say this is the first solution, because remember this part here is the final answer. So we can actually go fill that in as 48%, which is 0.48, and its volume is 15. Okay, so we've got that. Now for this next part, we've got 0.55 over here, but we don't know how much of this soil. Okay, we don't know how much, so we just say X, and then we've got this. Oh, then we've got this 40% clay. So we've got 2 types of soil. We've got a 55% soil and a 40% soil. So this would be a 40% soil, but we don't know how much. We can't say X because then you're saying that these 2 are the same mass, but they may not be. So we'll say Y. Now who can see what the problem is here? Hope you can see it. We have 2 unknowns. How can we solve? We cannot. But what we know is that this mass or volume plus this mass or volume must always give us this one. So we know that x plus y must always give us 15, right? Because that's what we've said in previous statements, that the mass or volume of solution 1 plus the mass or volume of solution 2 must always give us the mass or volume of solution 3. Or sorry, the final solution. So what you can do now is you can try to get either the x by itself in this formula, or you can get the y by itself. It doesn't really matter. Let's get the y by itself, okay? So that would give us 15 minus x. Okay, so then what we do is that we can now take this expression and replace this y over here. So that means that this y can be replaced with 15 minus x. If you've ever done simultaneous equations, we're almost doing something similar to that. So this would be 0.55x plus 0.4, and then in brackets we're going to replace the y as 15 minus x, because we said that y is the same as 15 minus x, so we can just use that instead. And then these two we can just go ahead and multiply along, and that's 7.2. Okay, so now we just need to go ahead and distribute the 0.4 into the bracket. So 0.4 times 15 is 6. Whoops, what's that? 6. And then we're going to multiply it there, so it becomes minus 0.4x equals to 7.2. Now we just move all the x's to the one side, all the numbers to the other side. And so what we end up with is 0.55x minus 0.4x equals to 7.2 minus 6. And so now on the left we end up with 0.15. And then on the right, we end up with, sorry, that says 7.2. That's going to be 1.2. And so if you then had to get x by itself, you would get 1.2 divided by 0.15. And so x is 8. Okay, so we know that the first solution, we should use 8 meters cubed of that one, 8 meters cubed. And then we can easily go and find the y value now by just coming back to this equation. Because if we use 8 of this one, then we obviously need to use 7 of the other one, because the total volume must be 15. But if you just had to use this formula, you would say that y is equal to 15 minus 8, and so that would be 7 meters cubed. So let's answer their question properly now. So we will need 8 meters cube of 55% clay and 7 meters cube of 40% clay. Alright, hope that makes sense. Here's our last question. Imani asked you to make 15 gallons of fruit that contains 47% fruit juice. Okay, so that is the final mixture that we are looking for. So if we had to do our bracket method, that is what the person wants at the very end. So they want 47%, which is 0.47, and they want the final volume to be 15 gallons. Okay? So how are we going to make this mixture up? Well, we're going to mix together some of brand A. So this could be brand A and some of brand B. Now, we don't know how much of each one, but we do know that brand A is a 55% mixture. So that's a 55% fruit juice. So we can just say X over here. And then brand B is a 40% mixture. So that's 0.4. And we can just call that Y. But now we know the total volume is 15. So we know that X plus Y must give us 15 from this formula that we normally look at down here. So we can make a formula now and say X plus Y equals to 15, like we did in the previous the previous question in this video. And now we can get Y by itself, for example. You could also get X by itself. It doesn't really matter. And now we can use this in the place of that over there. And so that's going to end up giving us 0.55x plus 0.4. Now we're going to replace this y with 15 minus x, and that's going to be equal to, now this I'm just going to type in on the calculator so long, 7.05, and now we say 0.55x plus, now we just distribute the 0.4 in, so that would be 6 minus 0.4x equals to 7.05. And now I'm just going to take all the x's to the one side and all the numbers to the other side. Okay, and so if we put these together, that'll just give us 0.15x, and then if we put this together, that'll be 1.05, and so x is equal to 7. Okay, and then we can also go get y now by just saying that y is equal to 15 minus x, which is 7, and that would give us 8. So now we answer their question. We say, therefore, we can use, what did we get for x? 7 gallons, 7 gallons of brand A, and then 8, did we get 8? Yeah, 8 gallons of brand B.